Sathyabama Institute of Science and Technology.
Hello everyone, this is Dr.B.U.Anu working as an assistant professor in the Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. So in this session we are going to discuss about what is linked list, the difference between array and linked list, and also we are going to discuss about the types of linked list, and finally we are going to see the implementation of linked list using C language. Let us consider, so our target is to arrange the following name of the students according to the first letter of the names. So this is the unordered list. We have Mikey, Radha, Jack, Surya, Anu, Mano and Tony. Okay, so we have to arrange this particular name in alphabetical order in a sequential manner. So after sequential manner, the name would be Anu, Jack, Mano, Mikey, Radha, Surya and Tony. Right? The question is how this particular list you can be maintained in the memory. That is a question, right? So we'll see one example. So there are two ways to maintain the list in the memory. Number one is by using an array, and number two is linked list. So array is a set of elements and it is stored in the consecutive memory location. One by one, right? And in the linked list we have represented the data as a node. So this is a node. Node can be of two types. One is data and second one is address of the next node, right? Let us consider here the address of the first node would be 200 and the address of second node would be 300. So here it would be data would be 6 and the address would be 300. 300 is the address of the second node. So in this way we will represent the linked list. Let us see what is the actual disadvantages of array, why we are moving on to linked list, right? So say for example, we are initializing integer a. What is the size of the integer? In 32-bit machine it can be 4 bytes. Okay, so 4 bytes from 204 to 207, 4 bytes will be allocated and the value is 5. So suppose we are giving another two elements, that is integer b of 2. So totally it will occupy 4 into 2, 8 bytes, right? So 8 bytes starting from 200, 201, 2, 3, 4 bytes will be allocated, but here we are allocating another element 5 is already there. So what? So we can't do that in a single block. So we have to do it in a separate block. That is a disadvantage over arrays, but in the linked list we can easily insert the element and we can do other operations also. So here we have a node. So linked list can be represented by means of node, and we have two parts, 4 and the address of the, this is your data part and this is the address of the next node. Say for example, we have two blocks, one is 4, this is first node, and number 6 is the second node, right? So what is the starting address of the node 1? That is 200. So 200 will be the first number. The 200 is the memory location for the first node and 205 is a memory location of the second node. So you know the actual node representation. Node representation consists of two parts. One is a data part and number 2 it's a address part of the next node. Okay, so here 6 and always the last node will end up with the null element, that is 0, or we can say it is a null. So how to represent the linked list? That is the important thing. So this is the way in which we represent the array. So this is not correct for linked list. So we have to represent it as in the user defined data type. In C language we will represent it as structure node. So we have structure node, we have two particular parts. One part is a data and another part is a address. So we have structure node. This is a user defined data type, open parenthesis. So we have two parts, right? One is for data part, you have to give it as integer a, and second one is what? Struct node. Struct node is nothing but it is a self-referential structure which denotes a pointer to the structure, right? So struct node star link, or you can give star next, like integer star a, we can give it as struct node. Since it is a user defined data type, we are giving struct node star link. So struct node is a self-referential structure. Next we are going to discuss about the types of linked lists, right? We have 4 types. First one is singly linked list, number 2 is doubly linked list, number 3 is circular linked list, Number 4 is doubly circular linked list. We are going to see one by one with an example. First one is a singly linked list. If we say linked list, then it is a singly linked list, right? So singly linked list consists of actually nodes which contain a data part and address part, right? So here we see how many elements we are going to store in the memory? 3 elements. So what are the 3 elements? 15, 25 and 35, right? So here we have a head node which always points to the first node. Head node always points to the first node, and always your last node end up with the null value, right? So here we have 3 parts: 15, 200. 200 is the address of the next node, okay, and we have 25, so 300. 300 is the address of the third node, right? So here we have no links, so we will put null value or a 0 value, okay. So how to represent a structure node? So it is similar to that previous example what we have discussed. So struct node is a user defined type, and we have 2 parts. One is integer a, and this is a self referential structure. So struct node starling, or you can give star next. So this is your doubly linked list. So this is a structure of doubly linked list. We have 3 parts, namely pointer 1, data and pointer 2, right? So pointer 1, we will say that previous node's address, will store previous node's address, and here pointer 2 will store the address of the next node, okay. So here what we are doing now, we have 3 particular links, 3 particular nodes, in which the first node's pointer 1 will be null, and last node's last address, that is pointer 2, would be null, right? So here we have a data like 5, 15 and 20. So we have 3 data, and 200 is the address of the next node, okay. So in doubly linked list we have 2 directions, one is forward direction and another one is backward direction, right? So here we will go for 200, and 100 is the address of the previous node, and 15 is the data, 300 is the address of the next node, and we have 220. Always in the doubly linked list, the last address, that is your next address, would be null, and here the first node's address would be null, that is the pointer 1 would be null, okay. So this is your doubly linked list. Next we are going to see about circular linked list, right? There is a slight difference between singly linked list and circular linked list. What is the difference actually means? In the singly linked list, the last node's address would be null, but here what we are doing now, the last node address will be the first node's address. It's like a circle, okay. So that is circular linked list, and this is the format for this is a different definition for circular linked list, which is same as singly linked list, okay. Struct node, and we have integer a, struct node star link. So this is a self-referential structure, and this is a user-defined data type, right? So this is called a circular linked list. So what is circular linked list? The last node's address would be the first node's address. Last node's address will be the first node's address, that is 100, okay. Next we are going to see about circular doubly linked list. So it is a combination of doubly linked list and circular linked list, right? So you all know doubly linked list we have 3 parts, namely the pointer 1, data and pointer 2, right? And we are going to merge with the double linked list plus the circular linked list. So here what we are doing now, first nodes, there is only one difference. The first node's address, that is your pointer 1, would be the last node's address. The first node's, so this is your pointer 1, right? This is your pointer 1. So this address will be the last node's address, and here we will store the first node's address. Last node's pointer 2 is the first node address, right? So in the doubly linked list is a combination of both circular linked list and doubly linked list. So this is the definition for circular doubly linked list, which is same as doubly linked list, right? So struct node, this is a user defined data type, and integer a, this is for storing the data, and we have 2 links, right? One is for next pointer, and struct node, one is another is for previous. So we have 2 pointers, one is next and previous. So this is called a circular doubly linked list. Next we are going to see the implementation of linked list. Implementation of linked list is nothing but implementation of singly linked list, right? So here, so this is the node we are going to create. So we are going to create 3 nodes, 1, 2 and 3, and what are the values? 15. So 200 is the address of the second node, and we have second node's data is 25, and 300 is the address of the third node, and third node is we have data as 35, and the value would be null. Okay, this only we are going to create using C language, right? So how to create? I'll first we are going to create the first node. Initially the value of head is equal to 0, right? So next we are going to create the first node. So first node how to create, I will be explaining in the next slide. Next we are going to see the implementation of linked list using C language. Here we have struct node. So struct node is a it's not a memory allocation, it is a define, it is used to defining the node. Okay, struct node, we have two parts, one is a data part, so we have to give integer a, and next one is struct node star link. So this is nothing but self-referential structure. Okay, so here we'll so see we have two parts, one is a data part and another one is a address part. Initially the value of address part would be null. Okay, what we are doing now, structure node, head node. Head node, what is head node? Head node always pointing to the first node of the linked list. Okay, so head node, so we are using 3 pointers, one is head node and another one is new node, which is nothing but we are going to create a memory allocation for a new node, and we are using another one pointer variable called temp, which is nothing but temporary variable which is used to traverse the element from first node till last node. Okay, so here what we are doing now, head is equal to 0. Initially the value of head is equal to 0. So now we are going to allocate the memory. So since we are going to do dynamic memory allocation, so we have a function called malloc, right? Malloc is used to create a dynamic memory allocation, and we are going to find the size of struct node. What is the size of struct node? 4 bytes for this storing the data and 4 bytes for storing the address. Okay, so malloc size of struct, so it will return 8 bytes, right? 8 bytes it will give an allocation in the memory, and here we have struct node star. Struct node star is nothing but it is used to typecast. That is a major thing, typecasting, which is we are going to use struct node star, and we are storing this value in the new node. So new node, actually we have a pointer called new node. So new node contains the address of the first node. So let us consider this example. So this is your new node. This is let us consider the address is 100. So 100 is equal to new node, and we are going to make first the head is equal to 0, then you have to put head is equal to new node. So what is the value of new node? 100. 100 will be stored in the head. After creating the memory allocation, we are going to enter the data into the list. Okay, so printf enter the data to be inserted in the node. So first part is the data part, right? In the data part we are going to enter the data. So since it is a structure, what I am doing, scanf %d, what you have to do, ampersand new node, ampersand, in the new node only we are going to add the data, right? So ampersand new node arrow operator. So you all know you have used structures, right? In the structures we will use arrow operator to access the member of the structure. Okay, so ampersand new node arrow mark a. So this is used to get the data from the user, right? And number 2, so you all know, right? In the first node the address would be null value. So what I am giving, new node's link is equal to 0. Now we have created the first node. Okay, obviously we have to create the other nodes also. So first what we are doing, if head is equal to 0, what you have to do, you have to put the new node's address to the head. Okay, please, so we are using one more variable temp, that I will explain it later. Okay, so first what we are doing, we are doing the new node's address to the head. Okay, then else if head is equal to 0, not equal to 0, then what you have to do, you are going to create the second node. That is important. So second node. So what is actually our second node? So we have created the first node 15 and null. Next what you are going to do, you are going to create the second node. What is the value of second node? 25, and the address is 300, right? So what you have to do now, you have to put the address is stored in the new node. So you are going to put this as a new node is equal to temp. You can initialize a temp variable here. So we have 3 pointers, one is head and another one is new node and number 3 is temp. Why we are using temp variable? Because we cannot move the head pointer to the consecutive nodes. So we are using the temp variable. So here temp is equal to head. Okay, so initially the value of temp is equal to 100. Okay, what is the next one? We are moving the temp to temp next, right? Temp is equal to temp next. So temp next is 200. So temp will come here, and what we are doing here? We are storing this 300 from the next node. Initially it is null. Okay, so here what we are doing now? Head is equal to temp is equal to new node. So new node is equal to temp is equal to head. Else if the head is not equal to 0, then we are going to create the second and third nodes consecutively, right? So here what I am doing, temp next is equal to new node. So okay, so we are storing the temp next. What is temp next? In the previous example 200, right? So temp next is equal to new node, then we are using temp is equal to new node. So now the temp will be moved to the second node, right? So what we are doing, so you have to continue this process until some point, right? So here what I am giving, printf, do you want to continue? So I am giving the choice. If you want to continue, you can create a nodes. Okay, so if you want to continue, you can create the nodes. So only I have given printf, do you want to continue? Okay, next. This part is used to traverse the linked list from the first node till the last node. Okay, so here what I am giving, temp is equal to head. Okay, so temp is equal to head. So what is temp? To 100. Okay, 100 would be stored in the temp. Okay, so here temp is here now, right? So what we are doing, we want to print the data element. How to print the data elements? Printf %d, then you have to give new nodes data. So temp data. So temp data is 15 will be printed, and you want to move the temp to the next node. Okay, how to do that? Temp is equal to temp next. What is temp next? 200. So temp will be here. Next what we are doing, we are going to print the value of the second node. What is the second node's value? 25. So temp next temp is equal to temp next, it will move on to the next node. What is the data value we are to print? 35. So that's all about the traversing. So here we are having temp is equal to head. You have to check while temp is not equal to 0. So the last node's address will always be 0, right? So what I am checking, while temp is not equal to 0, then printf temp data, what we have discussed in the previous slide. So we are going to print the data one by one. Okay, then we are moving the temp to the next node. Okay, this can be done until temp is not equal to 0. So this is a simple implementation of singly linked list. So we'll see then the next video lecture the other types of the linked list. Thank you.